Solve x to the fourth minus 10x squared plus 9 equals 0. This looks similar to a quadratic equation, but there is a big difference. The powers of x are off. Instead of having an x squared term, we have an x to the fourth, and instead of having an x term, we have x squared. This is still similar to a quadratic equation, though, because we've got three terms, two of which have the variable and one of which is constant. And this ends up being something that's in quadratic form, and we can actually turn it into a quadratic equation by making a z substitution, which is something that we did earlier when we were looking at factoring methods. So I'm going to rewrite the problem here. X to the fourth minus 10x squared plus 9 equals 0. And when we tried to put something in quadratic form, we wanted the first term to be something squared. And since there's no coefficient here, we're not going to have a coefficient there. Then we wanted the middle term to have that same quantity but not squared, just the same thing in parentheses. And then plus the constant equals 0. And to figure out what substitution we need to make, we want to figure out what quantity we can put in both of these sets of parentheses so that the new equation matches the original one. And in this case, that quantity is x squared, because if we take x squared and square it, that's what gives us x to the fourth. And plugging in x squared here also matches those terms up. So in this case, the substitution we're going to want to make is we're going to want to make z be x squared. And when we replace x squared with z, this equation turns into z squared minus 10z plus 9 equals 0. And now this is a quadratic equation. We've got ax squared or az squared plus bz plus c equals 0. And this we can solve by factoring. We can use the unfoiling method here. We need two numbers that have a product of 9 and a sum of negative 10. Those numbers are negative 9 and negative 1. So this factors into z minus 9 times z minus 1 equals 0. Now we can use the zero factor property to set each of these factors equal to 0. So z minus 9 equals 0, or z minus 1 equals 0. And when we solve each of these equations, we get z equals 9, or z equals 1. Now we're not finished with the problem, because we were asked to solve an equation with x's in it. So what we need to do is solve for x, but in this case we've solved for z. But it's pretty easy to go back from z's to x's. We can just redo the substitution, but in the other direction now. So wherever we see a z, we're going to replace it with an x squared. So this gives us x squared equals 9, or x squared equals 1. And these equations can be solved using the square root property. Whenever we have something squared equals a number, we can take the square root of both sides. For this first equation, the square root of x squared is x. And on the right-hand side, when we take the square root, we get plus or minus 3. In the second equation, when we take the square root of x squared, we get x. And on the right-hand side, when we take the square root, we get plus or minus 1. And so there are actually 4 solutions. Those solutions are positive 3, negative 3, positive 1, and negative 1. We could write all of them out if we wanted to. In fact, this one time I will. X equals 3, x equals negative 3, x equals 1, or x equals negative 1. But usually it suffices to write the solution just like this. X equals plus or minus 3, or x equals plus or minus 1. This is our final answer.